Hello, welcome back. Back to integration now. So look, method 1 was a direct application of the formula. Method 2 was substitution. We had 2a, 2b, 2c, 2d. Then I did exponential. And then I introduced you to f dash of x over f of x. So I can't remember the method number now, I have forgotten. So I will have to find out which method it is. It doesn't matter. So this is, let me put it as integrating rational expressions, meaning algebraic fractions, trigonometric fractions, and so on. Remember, I told you the most important formula in integration or the way you remember is if the numerator is exact derivative of denominator, the answer is log denominator. So let's take some simple examples. Find number 1 integral 1 over 3 minus 2x dx. I could use the first method, direct application, but there is a better way, especially with fractions. What you get when you differentiate this, you do mentally, but to make you understand, I will write it. Oh, by the way, my name is Sosale Mohana. I have taught A-level math for a long time, and I'm trying to record these lessons to help you go over various topics in pure maths as a revision of what you have learned in school, during your math lessons with your teachers, and to help you prepare for your exams. Okay? Right. Now, which is only a minus 2, which is a constant, isn't it? So therefore, can I write it as minus 2 over 3 minus 2x dx? Why? Because if the numerator is exact derivative of the denominator, the answer is ln denominator. Yeah? So, but the question was 1, I wrote minus 2, so I put 1 over minus 2. You adjust the constant, but please, if it is 3x squared, 3 minus 2x squared, you require a minus 4x, but you can't say 1 over 4x outside. Why? X is a variable. You can only multiply or divide by a constant, not a variable. Outside the integral. Inside the integral we can, which I will show you later. So therefore, which is minus half ln 3 minus 2x plus c. Simple. There's only one mark for this. This you do mentally, that you do mentally, or the other way, going back to basic. When can you apply the formula directly? If the derivative is a constant. The derivative is a constant. So 1 over x gives you ln x, 1 over y gives you ln y, 1 over 3 minus 2x gives you ln 3 minus 2x. Then divide your answer by the constant you get on differentiation. The constant I got was minus 2, so I divided by minus. So you can do it that way as well. But I want you to get used to numerator being derivative of a constant. Oh, sorry. Numerator being idiot. Numerator being the exact derivative of the denominator. Whereas, suppose I had integral 3x over x squared plus 4 dx. Well, the more complicated function is x squared plus 4. When I differentiate, I get 2x, which is not a constant. But I have an x in the numerator, so method 2a. I have a function and its derivative. Call the function as u, find du by dx, make dx the subject, substitute, cancel, you get a simple integral in u, you can integrate and then come back. Yes, perfectly correct. But why? No, if I were to eat a piece of sweet, or if I eat some food, I can eat like this. Why should I take here and then take it from behind, bring it here and then eat it? Why? If you can use the simplest method, the numerator must be exact derivative of the denominator. Look, 3 is a constant. So anytime you have a constant in the integral, unless needed, take it outside. When I differentiate x squared plus 4, I get 2x. I have an x, so what's missing? I need to multiply by 2. And 2 is a constant. I can only multiply by a constant. So I multiply by 2, I divide by 2. Here the numerator is exact derivative of denominator. So the answer is ln denominator. Much simpler than inspection, substitution, so many other methods. Okay. Let me take another example. Suppose I had four minus 3x over x minus 2. It's an algebraic fraction. Always, whenever it's a fraction, you always look at the denominator to start with. When you differentiate, I get 1. The numerator is not a constant, I got a 3x as well. What is the fundamental rule you think of when we did partial fractions? It should be a proper fraction. What do you mean by a proper fraction? The numerator must be smaller than the denominator. That's in arithmetic. What about algebra? The highest power in the numerator must be smaller than the highest power in the denominator. If the highest power in the numerator is equal to or more than the highest power in the denominator, you have to divide and make it into a proper fraction. So, ladies and gentlemen, I divide this. To get minus 3x, so it's minus 3x plus 6. And for those who find it confusing, write it as minus 3x plus 4. So it's minus 2. So it is integral minus 3 minus 2 over x minus 2 dx. Look, minus 3 plus 6 minus 2 is 4. Minus 3 gives you, so minus 3x. Minus 2 is a constant, 1 over x minus 2 dx. What do you get when you differentiate x minus 2? I get 1. What's the numerator? 1. So numerator is f dash of x, denominator is f of x. So it is minus 3x minus 2 ln x minus 2 plus. So if the power of the numerator equals power of denominator, or if the power of numerator is more than the power of denominator, you have to first divide and then integrate. That was why we did partial fractions. As I will jump to partial fraction, questions on partial fractions, then I come back to more complicated questions in integration. Right. They will not say use partial fractions. Sometimes, yeah, they tell you resolve this into partial fractions and hence. Sometimes they don't. So suppose I had integral 7x plus 2 over 3x cubed plus x squared. When I differentiate the denominator, I get 9x squared plus 2x. I don't have an x squared, so I can't use substitution. It's a proper fraction or proper rational expression because the power of numerator is smaller than the power of denominator. So the only choice you have is partial fractions. What are the steps? Factorize the denominator. Okay. Whoops. Oh yeah, it's okay. So it's x squared times 3x plus 1. Correct? Very good. X squared will have two fractions because it's a repeated factor, and 3x plus 1. That's an A, that's a B, that's a C. Now do you understand why I had to go back and do partial fractions? Because I need it here. Multiply throughout by x squared times 3x plus 1. So you get 7x plus 2. Sorry, I should put identical. 2ax times 3x plus 1 plus b times 3x plus 1 plus c x squared. Okay, put x equal to minus 1/3. Minus 7 over 3 plus 2, 0, 0 equal to c over 9. So minus 1 over 3 is c over 9. So c is minus 3. Yeah. Is that correct? Yeah, it is. Is it? Minus 7 over 3, 6, so minus 1 over 3, minus 1 over 3 squared is 1 over 9, yeah, c is minus 3, okay. Put x as 0. That's gone, I get 2 equal to b. Now I can't use 0, can use any value you want. I need to find what is a, isn't it? I can compare coefficients. I can straight away say, I think a will be minus 1. Doesn't matter. Put x as 1. What do I get? 7 plus 2, 9 equal to 4a plus 4b plus c. So 4a equal to 9 minus 8 plus 3. So a is 1. Am I correct? X is 1, 9, 3 plus 1, 4, 4a, 4b, c. So 4a equal to 9 minus 4b is 8, so minus 8 minus c is plus 3. Also a is 1. So it becomes integral a is 1. 1 over x dx split into 3 integrals. b is 2 plus integral 2 over x squared dx minus 3 integral 1 over 3x plus 1 dx. That was the reason why you did partial fractions. In Edexcel, I don't think they do it in OCR in general, but in Edexcel, they will tell you, given that, find a, b and c. Make life easy for you. Okay. Now let's integrate that. That was why we had to do partial fractions. This is straightforward. Now, ladies and gentlemen, this is again something I have come across. So 1 over s gives you ln x. So 1 over x squared gives you ln x squared. Matches my grandfather's property. It's only when the power of the denominator is 1. 1 over x is ln. 1 over x squared is not ln. So this actually 2 integral x power minus 2 dx. It gives you 2x power minus 1 over minus 1 minus, see what I'm doing, I've not written that. I've got a 3x plus 1. What do you get when you differentiate the denominator? Well, before I do that, remember, to use log, the numerator must be exact derivative of denominator. So if you told me ln x squared, what is the derivative of x squared? 2x. Do you have an x in the top? No. So you can't use ln. Okay. When you differentiate 3x plus 1, I get a 3. I had a 3 there, so I could bring the 3 there. So it becomes ln x minus 2 over x minus ln 3x plus 1 plus c. Yeah? Good. Let me take one more interesting question. Integral x over 25 minus x squared dx. So obviously, the power of numerator is 1, power of denominator is 2. I can factorize it. We have just done partial fractions, so there I can see some people taking a pen and paper and saying like this. A over 5 minus x plus, excuse me, b over 5 plus x, blah, blah, blah. Ladies and gentlemen, I always tell you, God has given us brains. The moment you see a fraction, number one, check whether it's a proper fraction. Number two, differentiate the denominator first. If you can get f dash of x or f of x, life is much easier. So don't blindly do partial fractions. So, it's a proper fraction. What do you get when you differentiate 25 minus x squared? I get minus 2x. I have an x. What do I need? Minus 2. So can I say minus half integral minus 2x over 25 minus x squared dx? Numerator is exact derivative of denominator. So the answer is ln denominator. So it's minus half ln 25 minus x squared dx. Oh, sorry, plus c. I hope I've been putting plus c, otherwise I'm losing a mark every time. Or I can say ln 1 over square root 25 minus x squared plus. Can do that as well. So don't blindly use partial fractions. Stop and think. Okay, I've taken about 17 minutes. I'll stop there. I'll just do one more lesson on integrating rational expressions and maybe two more, taking some trigonometric expressions and so on, before I start with the next topic, which all of you will enjoy, integrating trigonometric functions. God bless you. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.